to this video. This is Unzadani. So in this video, this is biochemistry. So in this video we are going to talk about regulation of glycolysis, because the first video that was posted on YouTube we talked glycolysis pathway. So in this video we are going to strictly talk about the regulation of this glycolysis. So we need to understand that glycolysis is controlled or regulated by three irreversible reactions. So the first reaction, we have this one. So this is glucose. So glucose has to be converted to glucose 6 phosphate. So the enzyme that is involved here, hexokinase. Hexokinase. Then we have the second one. So the second one involves conversion of fructose 6 phosphate to fructose 1,6 biphosphate. So here the enzyme that is involved is PFK1, which is the most important enzyme here, since this step is the one that we call the control step. I mean the committed step, this one here. So we need to take note. The conversion of fructose 6 phosphate to fructose 1,6 biphosphate. So this is the committed step. Committed. So why is it called the committed step? So this is because it commits glucose into the glycolytic pathway. So once fructose 6 phosphate is converted to fructose 1,6 biphosphate, so that means there is no going back. So that's why this step is called the committed step. So let's look at the other step, the control step. So we've looked at 2. So let's look at the third one. So the third one involves the conversion of phosphoenolpyruvate to pyruvate. So here the enzyme that is involved here is pyruvate kinase. Pyruvate kinase. Pyruvate kinase. So as we have seen, these are the control steps of the glycolysis pathway. The enzyme of this cycle. So we have one. That regulate glycolysis. So the first enzyme here we have PFK, which is for the committed step. So we have PFK, which is phosphofructokinase. This one catalyzes the conversion of fructose 6 phosphate to fructose 6 phosphate. I'll just use abbreviations here since we already wrote them at the top here. So 6 phosphate to fructose 1,6 biphosphate. Biphosphate. So how does this enzyme regulate glycolysis? So first we have A. So we have high levels of ATP. ATP inhibits the enzyme. So why does high levels of ATP inhibit the enzyme? So this is because high ATP levels lowers affinity of PFK to fructose 6 phosphate. It lowers affinity. Since fructose 6 phosphate is the substrate here. So here, since the essence of glycolysis is to break down glucose to form energy, which is ATP. Since ATP is the currency of energy for the cells, so when you have high levels of ATP, so this tells you to say there is enough energy in the system, so there is no need to continue making more energy. So that's why this ATP here, high levels of ATP, will lower the affinity of the enzyme PFK to bind to phosphate 6, fructose 6 phosphate. So the other thing, let's see the curve now. So this one, high levels of ATP, will shift the curve, the parabolic curve, to change the parabolic curve to sigmoid, to a sigmoid curve. So we have this curve here. So this is reaction velocity. Reaction velocity. Then we have fructose 6 phosphate. So let's use green. So when you have low levels of ATP, so that means there will be high affinity. So it will be moving like this. Be moving like this. But when ATP, so this is low ATP. But once ATP increases, it will move like this. It will be moving like this. So this is high ATP concentration. Yeah. So that's how it is. So the other thing, so to reverse this process, so MP reverses the inhibitory activity of ATP. Since adenosine monophosphate is a substrate, it's one thing that is used to make ATP. So when you have high levels of this one, so this one tells you to say there is need to make more ATP. So that's why this one reverses the inhibitory activity of ATP. So that means when you have a low ATP AMP ratio. So what does that mean? So we have ATP at the top, then AMP down. So when you have a low ratio here, for example, you have half. So ATP, then AMP. So when you have a low ratio here, when the value is low here, so that means the activity of the enzyme increases. Okay, let's say ATP is equal to 3, then AMP is equal to is equal to 6. Then the other one we have ATP is equal to 6, A is equal to 3. So the ratio here will be ATP to AMP we equal to, so ATP we have 3, then AMP we have 6, so which is 3 over 6, which is 1 over 2. What about here? We have So the ratio here will be 6/3. So we have 2. So as you can see, this is half and this is 2 here. So they are saying low ATP AMP ratio increases the activity of the enzyme. So which one has got a low ratio here? So we have this one, where you have a lot of AMP and low ATP. So that's why we say this AMP here is what reverses the activity of inhibitory activity of ATP. So let's go to the next thing. So the second thing,
by a drop in pH.
by an appreciable, which is a high pH, change in pH. So when pH drops, so that means that is acidic. Acid becomes acidic. So what they mean here is that H plus ions, when H plus ions are increased, so that means you have a low pH. So this one prevents formation formation of lactate and the and a drop in blood pH to acidosis lactate. So when the pH here is low, so that means there will be low formation of lactate. So PFK is inhibited by a low pH, which means high concentration of hydroxide ions. So this lactate just signals that you have a lot of substrate that are used to synthesize other biomolecules. That's what it says here. So there is no need to synthesize here since we are breaking down glucose. So when you have this one, low levels of this lactate, so that means the PFK is inhibited. So let's go to the next one. See the levels of citrate. So PFK inhibited by citrate. So this one enhances the inhibitory activity of ATP. So why does this citrate inhibit PFK activity?
of citrate
Indicates an abundance of biosynthetic precursors. So the precursors being talked about are, for example, pyruvate. Since when we are breaking down glucose, we are breaking it to pyruvate. So when you have a lot of pyruvate, so that means there is no need to break down glucose. Hence, citrate inhibits PFK. So let's go to the last one on the PFK. So we have the D. So PFK in the liver is activated by fructose 2,6 biphosphate phosphate, and this brings an increase, and this FK's affinity for fructose 6 phosphate to 6 phosphate. So this one increases the PFK's affinity for fructose 6 phosphate when you have fructose 6 biphosphate. And when PFK is activated, so that means you diminish inhibitory activity of of ATP, not PFK, of ATP, of ATP. So where does the fructose 2,6 biphosphate come from? Let's break it down.
So then you have the enzyme
PFK2. So the first one was PFK1. So this is PFK2. So this is fructose 2 kinase. So you have fructose 2 6 phosphate. So that's where this fructose 2,6 biphosphate comes from. This is biphosphate here. Biphosphate. So this enzyme here
this is phosphofructokinase.
phosphofructokinase. So this is a bifunctional enzyme. Bifunctional enzyme. So that means that it controls the balance between gluconeogenesis and glycolysis. So remember, gluconeogenesis, this is just the formation of glucose from other non-protein, non-carbohydrate biomolecules like amino acids and fatty acids. So this is through synthesis and degradation.